briefly. I welcome you all this morning at Manila and whatever the time zones may be. Thanks a lot for taking the time out to join us. We are here gathered to do the first of a series of webinars on natural capital under the NCL webinar series. My name is Narayan and I'm part of the AFNR sector group working in the sector office. So why is this? I would just like to tell you a little bit about why we organized this webinar series at all. So ADB has a well-established now ambition of being a leading climate bank, and we're also battling an intense you could say war against food insecurity. We wanted to highlight the fact that there is a very strong nexus among climate change, food insecurity, and nature. And they are also interwoven with each other, that any adverse effect to one of them causes adverse effect on the other, and the reverse is also true. So the way that we thought a sustainable way to break this vicious cycle is to invest a lot more in nature. And it's quite an established fact that nature and agri-food systems actually go hand in hand. There are studies out in the public domain which show that investing in agri-food systems actually solves, or investing in nature, impacts about 75% of the impact that is caused in the other. So you invest in nature, you're impacting about 75% of the agri-food systems, and vice versa. So we thought that we need to bring about this awareness, heighten this awareness, and discuss various aspects that could help in growing both sustainable agri-food systems for long-term food security and growing, conserving, protecting nature. So without much ado, let me introduce our speakers for today as we come along. I would like to first request Qingfeng Zhang, who is Senior Director overseeing ADB's AFNR operations. Besides his rich operations experience at ADB, Qingfeng has also published over dozens of knowledge products, op-eds, and blogs. He holds a doctoral degree in environmental engineering from Tsinghua University. Qingfeng, over to you for some welcome remarks.
Yes, thank you so much, Larry. Also welcome everyone virtually attended this very important session. So again, this is one of the difficulty for this digital technology. I want to take this opportunity to share three observations on the way forward for this natural capital live series. Number one, again, Asia Pacific, we are facing a triple crisis, but very importantly for us to introduce these measures addresses the climate food natural nexus. Asia Pacific is one of the most diverse regions in the world. It is home to the 17th of 66 global biodiversity hotspots, and also 7 of the 17 medical diverse countries, and the greatest is marine diversity. But however, many of the ecosystems in the region, from the tropical forest to the coral reefs, have already been degraded beyond the repair. But at the same time, Asia Pacific is also facing a severe food insecurity. Over half of the people in the world are affected by the hunger in the Asia and also the Pacific. Nearly 1.9 billion people in the region lack health diets due to the poverty and also showing food prices. So while the ADB's MTMCs are facing one or more issue of the malnutrition. So in the Asia Pacific, sustainable farming is one of the key areas ADB work with our DMCs. because ancestral sustainable farming practices is driven significant biodiversity loss. Traditional agricultural practices use 70% of the world resources, 50% of the habitable land, and also causes up to the 80% of the biodiversity loss. Biodiversity loss also undermines the ability of the ecosystem to adapt to these changes. Of course, leading to the exacerbation of climate change and the further decline in food security. So agriculture and the food system also account for 30% of the GHG emissions, which is significant due to the climate change. So climate change is also leading to the more frequent and intense weather events, which are disrupting the agriculture and the causes of widespread the food insecurity, further degraded this biodiversity. So the second point I want to share is the importance of this natural capital life. Investing in the natural capital is critical to break up of this vicious cycle, addresses climate food natural nexus. But however, as one of our community noted, the flow of the financial capital into the natural capital is not so straightforward. It's constrained by the number of factors, including lack of the clarity and the returns, lack of the reliable methodology for the accounting, perception of the high risk, and of course, is also an incentive, lack of incentives to incentivize the parties to invest in this very important area. Against this backdrop, ADB, Stanford, and many of the partners will jointly establish Asia Pacific Natural Capital Lab in 2021. This is a regional digital platform serving the test bed to integrate natural policy solutions in the project design and also leverage additional financial resources through the three key components. One is the natural capital variation, design the mechanism to value the nature as an asset, introduce the payment for ecological services mechanism, and also the introduce measures greening agro-business value chain process. Second is the institutional policy reform, introduce a regulatory reform to incentivize natural capital investment and also mitigate risk. Three is a sustainable and innovative finance, catalyze innovative and sustainable financing, mobilize private sector capital investment, and also leverage public financing. So today, we are going to review the progress we made and also discuss about the way forward. Again, out of these three key components, for the natural capital accounting, we made good progress already. Last April, Stanford with ADB, Inter-American Bank, World Bank, we jointly hosted the global forum for mainstreaming the natural capital in our decision making. We have the 15 DMCs to attend that forum. From Asia Pacific, we have the 5 DMC committed to conduct the natural capital assessment. And also we have the regional natural capital forum last November. We expanded the pilot to the 13 countries. Of course, this year we're going to discuss about the way forward in Stanford. Second is for the natural capital fund, we also make a good progress. Global Environmental Facility agreed to provide $15 million grant finance to support this fund. GAFSP, Global Agricultural Food Security Program, also agreed, committed, provide another $50 million. From the ADB end, we also coordinate with our ADB's ADA, ADF, also work together with Japan, South Korea, FCD, and many others to mobilize additional funding sources. Today, we need to discuss about a lot of key components. That is a policy reform, because policy tools such as subsidies, taxes, incentives, payment for ecological services is so critical. That is only way we can incentivize investment in the conservation and also sustainable use of the natural capital by providing financial rewards for the ecosystem stewardship and also sustainable resources management practices. This type of the policies encourages the business and also our landowners to prioritize long-term environmental sustainability over the short-term gains. Again, in Stanford this February, one of our FI get together, conducted a FI forum for a global food system transformation. We also agree to include the repurposing agricultural subsidy shifted towards a payment for ecological services as a key working group. We're going to work together across the world, the MDB, to enhance the natural capital investment. Of course, many of the countries in the Asia Pacific also introduced a regulatory reform to enabling natural capital investment. For example, PRC just going to release its first kind of the legislation on equal compensation next few weeks. And the FIR team, together with our Beijing office, is going to further important visit to Beijing, meet with the National Development and Reform Commission, discuss the options of leverage this legislation, the IDB operations. In Vietnam, IDB also going to work with the government to review the country's forest PES decree, which was released 3 years ago. Again, 160 countries signed the COP28 Declaration on the Sustainable Agricultural, Resilient Food Systems, and also climate actions. In COP 2030, one of the countries need to get together, discuss about the way of scale up. So that's going to be a great opportunity for one of us to report back what type of the policy incentive we can introduce, and also related to this sort of the one of the key DMC's commitment and also the declaration. So harmonize national policies with the international standards and the guidelines, very critical for the global cooperation and solidify our efforts to address this triple crisis, again, biodiversity losses, climate change, and the food insecurity. So next a few 60 minutes, we're going to hear the our speech and the presentation from our colleague from Stanford University and also Natural Capital Project. Of course, Steve is going to give a very, very important presentation. For all of the IDB colleagues, we're going to gain a rich perspective on the importance of the appropriate policy for natural capital investment, and then and also sort of introduce IDB operation scale for this type of the policies. Let me just pause here. I hope, I also wish one of our colleagues in this room and virtually, you can enjoy the discussion, and also you are proactively attended this enlightening and thought-provoking discussions. Thank you so much. Over back to you, Maria.
Thank you, Ching-Feng, for setting the context from ADB's perspective so clearly. May I now invite Mary Ruckelshaus from Stanford University. Mary Ruckelshaus oversees all work of the Natural Capital Project Partnership. And she has been a professor of biological sciences at Florida State University. She has also held several senior positions across organizations such as the TNC, Wild Salmon Center, and others. She has a doctoral degree in botany. Mary, the floor is yours. Mary, are you able to log in? Okay, perhaps Mary is having some issues connecting. We can probably have her speak whenever she is able to join. I would now like to request Professor Steve Pulaski to take the floor. As a brief introduction to Professor Pulaski, he's Regents Professor and Fessler-Lampert Professor of Ecological Environmental Economics at the University of Minnesota. And he's the co-founder of the Natural Capital Project that is housed at Stanford University as well. His research focuses on issues at the intersection of ecology and economics, including the value of ecosystem services and natural capital, biodiversity conservation, land use, sustainability, common property resources, and environmental regulation. He has served on the board of TNC, in the US President's Council of Economic Advisors, with the US EPA, as well as other responsible positions. May I invite Professor Pulaski?
Great. Thank you, Narayan. And thanks for the invitation to talk to you this morning. So I'll go ahead and share screen if that's okay.
Professor Pulaski, I think you're muted.
It shows it's not muted on my side.
Yeah, it's okay now. But it's very faint.
Okay. Can you hear me now? How's the sound?
Professor Pulaski, can you just try again?
Can you hear me now? No? I'm getting a thumbs up from one person, but not from Narayan, not from, okay. Sounds good? Okay, great. Okay, so thank you, Narayan and Jinfeng. I really appreciate the opportunity to speak with you. I'm going to go ahead and share screen and let me know if it's working here in a moment. Okay, should be shared. Great. Okay. So I have some remarks on the importance of bringing the value of nature, of natural capital and ecosystem services into economics, finance, and policy. I have some kind of opening, more introductory remarks. I'll try to go through those more quickly, and then I have a set of examples of where we have tried to operationalize or use this information about natural capital and ecosystem services, bring it into kind of an economic and policy framing. And I hopefully will whet your appetite with some of these examples, and happy to talk through any questions that you have. Okay, so as has already been stated, we do face some severe challenges, not only from trying to end poverty, but to do so in a sustainable way. So how do we bring people out of poverty while maintaining life support systems that underpin current and future well-being? So this is a question of not only economic development, but doing it in an environmentally sustainable way. The record of the recent past is that we've had rapid economic growth in many parts of the world. However, poverty remains prevalent, but we also have large declines in natural capital. So we've already, you've heard being spoken of the climate and biodiversity crises. So just some basics, because I don't know the background of everybody I'm speaking to. The wonders of Zoom, I'm not even sure who I'm speaking to, but anyway, so nature provides a wide array of benefits to people. These are called ecosystem services. Sometimes they're called nature's contributions to people. Sometimes they're called environmental services. These are provided by natural capital. So just in the way economists normally think about capital providing a flow of goods and services or a flow of benefits, you can think about natural capital as the set of assets that provide a flow of benefits from ecosystem services. Humans are transforming the planet. We are affecting natural capital and therefore the ecosystem services that they provide. Unfortunately, many of these ecosystem services are invisible to the economic system, the finance system, and so they're often not factored into important decisions that affect ecosystems. And distortions in decision-making damage the provision of these services, making human society and the environment poorer. So just to back this up, a few years ago, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, or IPBES, did a global assessment. As part of that global assessment, they not only demonstrated that biodiversity itself is declining, but that nature's contributions to people are declining. This is a very busy chart here, but the main point is the rows are different types of ecosystem services. Whether it's in orange or blue, if it's in orange, it's that the global trends over the past 50 years in that ecosystem service are declining. And you'll see this is the chart, which is dominated by orange, or declining ecosystem services. So over the past 50 years, we have done an amazing job as economists of raising global GDP, grown 6.5x. But at the same time, we've had a decline in natural capital. And as that previous figure showed, a decline in the majority of nature's contributions to people globally. A way of saying this for economists is you get what you pay for, and you don't get what you don't pay for, or you don't sustain what you don't pay for. So, you know, viewed as an economic point of view, and these are public goods oftentimes, or externalities, and therefore the things that private landowners or businesses find profitable versus what society as a whole would find beneficial do not line up. So there's a role here for policy to try to align, you know, to try to provide the right set of incentives so that what is privately profitable is also socially beneficial. And so the ideas behind the Natural Capital Project and trying to mainstream ecosystem services is that incorporating the multiple values of nature into economic incentives can generate better ecological, economic, and social outcomes. Okay, I'm going to give you just one slide of sort of how I think about framing these issues, where economics, where policy comes in. And then I'm going to provide a set of examples of how we can implement this approach. So I think this group in particular is interested in policy decisions that provide incentives for decisions that are made by households or by firms. The decisions of households and firms, whether it's farmers or whether it's businesses, they take actions that affect ecosystems. Sometimes my scientific friends will stop at this point and just point out the effects on ecosystems. However, here we want to go further. We want to use what we call ecological production functions, just like economists use production functions all the time to describe the provision of goods and services. Here we'll talk about the provision of ecosystem goods and services, which is a function of the structure and function of ecosystems. So people make changes to ecosystems that changes the flow of ecosystem services. So, you know, if a farmer, say, drains a wetland to grow crops, sure, they get the crops, but they've also changed the hydrology. They've changed the nutrient flow, which has a set of effects both there and then downstream. So we can think about those biophysical trade-offs, maybe in water quality versus food production or carbon sequestration or whatever. We can also go further as economists and apply valuation techniques to talk about the monetary value or the benefits and the costs, and think about what is economically efficient. Is it socially beneficial, for example, to drain a wetland in order to grow more crops? Is the value of the lost ecosystem services greater or less than the value of the crops? And there are other considerations of fairness and procedural matters and so forth. But the way I think about this is we're trying to provide good decisions so that we make policies, so that we provide incentives in order to get the highest flow of net benefits from the system. So what I'm going to do now is walk through 3 examples where we have done this sort of blending. So part of this is natural science, thinking about ecosystems, so ecological science, maybe it's hydrology, maybe it's climate science, but integrate that with an economic framing. So thinking about what is the provision of these valuable goods and services, you know, what are the benefits, what are the costs of taking various actions, and thinking about this in application in sort of 3 distinct, so these examples will show 3 distinct applications. The first one I'm going to talk about is what's called gross ecosystem product. So this is more in an accounting sense than a cost-benefit sense, which I'll talk about later on, or a macroeconomic application, which I'll talk about later on. And this is work that's been led by colleagues of ours in the Natural Capital Project at the Chinese Academy of Sciences. So some of you I know are familiar with China's efforts to develop a gross ecosystem product. The goals here are to reveal what is the contribution of nature to the economy and human well-being, show how those ecological connections lead to flows of services across local regions, across provinces, potentially across country lines. Maybe this can be the basis then for compensation from beneficiaries to suppliers of ecosystem services, and potentially serve as a performance metric for government officials. So not just did your GDP grow, but did your GEP grow? And the idea here is that GEP will be reported alongside of GDP. So the idea here is that, you know, we've had metrics of gross domestic product for quite some time. We have not had similar measures of ecological product or of the value of nature, and so GEP is meant to fill that void. It's important to note that there is overlap between GDP and GEP. So if you think about, for example, the value of agricultural crops, clearly there's a component of nature there, but agricultural crop value is also currently in GDP. So part of the role of GEP is to measure the non-marketed ecosystem services which do not show up currently in GDP. So what's the value of cleaner air or cleaner water, for example? But part of it is also to show the values of contributions to things that do show up in GDP. So what is the portion of agricultural crops which is really due to nature as opposed to human labor or machinery? So pollinators or clean water supply would be attributable as contributions of nature, whereas labor supply would be obviously a contribution of people. Just walking through very quickly at a high level, I'm happy to talk details if you wish. What do you need to do in order to compute GEP? So it's parallel to the steps you would need to compute GDP. First, we need to, here we need to track the magnitude and condition of the stocks of natural capital, because we want to then translate those into the flows of ecosystem goods and services. So if we know how much forest and wetlands and so forth that we have, and then we use models that predict the flows of ecosystem services as a function of the quantity and quality of the ecosystems, we can then predict the physical flows, biophysical flows of ecosystem goods and services. So, for example, in China, this is again work that was led by our colleagues at the Chinese Academy of Sciences on the various ecosystem services. So carbon sequestration and storage, for example, or soil retention, water retention, sandstorm prevention, and so forth. Just mapping out on the ecological, biophysical side, what is it that ecosystems are doing? What services are they providing? The third step then, besides kind of more of the natural, the first two steps are really more on the natural science side. The third step is translating this into economic values. As economists, we're used to doing this. So many ecosystem goods and services, some have market prices, in which case we can use those to help us put these benefits into monetary terms. Some do not, so we need to use non-market methods to evaluate market prices or the equivalent of market prices and value. So, you know, using non-market ecosystem goods and services methods, there are a variety of methods that can be used. Some, for example, if I'm thinking about something that does contribute to a marketed good, let's say pollination into agricultural crops, I can think about, just like I would think about what's the value of labor in producing the crops, I can think about how do the pollination services contribute to the provision of crops, either the increase in quantity or quality. We can also think about replacement costs. So if we didn't have an ecosystem filtering water and we had to build a water filtration plant, what would that cost to replace the service that's being provided by nature. And there are many other examples. Here I give an example of the value of water retention services for hydropower, which was done in China. The other example is a pollination for crop production that actually comes from Latin America. And again, replacement costs is another potential option, although there are some pitfalls with it. Like, for example, it must the way you're calculating replacement cost, it has to be that that's the lowest cost way of providing the good or service, and that people would actually be willing to pay that cost of replacement if it was lost from nature. Okay, in the case of providing clean water to metropolitan areas, those are probably both true, and so that's a valid approach, and it has been used in valuing preserving watersheds that provide clean drinking water to metropolitan areas. Okay, the last step, and I'm not going to go into any depth, is to aggregate across the goods and services all of the ecosystem goods and services in order to get GEP, being careful not to double count. For example, you cannot count both the value of pollinators and then the value of crops, because that's how we can, that's how we actually calculated the value of pollinators, was their contribution to crops. Okay, so in China, there have been a number of local and provincial level applications. We'll just show one briefly for Qinghai province, which is in Western China on the Tibetan Plateau. It's the headwaters of three major rivers, the Yellow, Yangtze, and Mekong River. We applied those steps. In China, we had access to the China Ecosystem Assessment, which is done every 5 years, to provide us snapshots through time of the quantity and quality of various types of natural capital. We used from the Natural Capital Project the invest models in order to calculate, as a function of those stocks of natural capital, what were the flows of ecosystem services. This shows maps of Qinghai and where those services are generated. The maps on the right are where are the beneficiaries of those services, and sometimes they're downstream, as for example, beneficiaries of water supply. Sometimes they're downwind, as an example of beneficiaries of sandstorm prevention. And sometimes, as in the case of ecotourism, they're spread on depending on who is it that's traveling to Qinghai for ecotourism. Don't want to dwell on this, but just as an indication of these are methods that can be applied, and we can come up with quantifiable values for ecosystem services. So sometimes I hear this point about, oh, I get it in principle, but this is really hard to do in practice, and the numbers, we just don't have numbers. Well, it is true that there are significant challenges in data that must be addressed, but this is doable. And in fact, now with colleagues at Chinese Academy of Sciences, we are applying this more broadly, doing this for 150 countries, at least as a first kind of proof of concept that we can capture the value, at least of major ecosystem goods and services. Okay. I'm going to talk very quickly about two other examples. These are less accounting and more in the realm of thinking about, in this case, thinking about what are our options, kind of how should we be using land? So using the notion of a production possibility frontier from economics, what is the best way of using land if we're trying to produce a set of ecosystem goods and services? Okay, so the goal here is to find land use patterns that optimize for multiple benefits. You can see the land uses, so it could be cropland for growing crops or for grazing. So for animals, we could also have forestry or leaving it as natural habitat. We're tracking multiple benefits in this exercise. So the net income, so really the gross income, so what are the revenues minus what are the cost of productions, generating the net income or the rents, carbon storage, and then measures of biodiversity. Okay, and I won't really go into the details, but again, it's the same type of flow. So we have, with the landscape alternatives, that sets where we have ecosystem assets or natural capital. We can change those and ask the question, how does the change in land use, the change in the pattern of natural capital lead to a change in the flow of ecosystem services? That's where we use these economic and environmental models from Invest or other places. Here we combine it with optimization methods in order to figure out what is the land use pattern that gives us a Pareto solution. In other words, I cannot increase any one good or service without reducing something else. And here you'll see, in fact, this is for economists, this will look very standard, right? It's like from a textbook, a production possibility frontier, where here the horizontal axis shows, as a function of the choices of land use and land management, and this is actually for the country of Paraguay, what are the net economic returns on the horizontal axis, and what are the, in this case, the net greenhouse gas storage on the vertical axis. The red dot here is where evaluating the current landscape, the current pattern. The blue line is the frontier found through optimization methods. And here with the yellow dots are just indicating potential Pareto moves that the country could make. And the maps here show what the landscape, land use and land management pattern looks like when you move to the frontier. Okay, so we did this for, this is work with colleagues at the World Bank. Did this for 150 countries. We got very different patterns across different countries. So here, sorry, I probably should have put Asia Pacific countries on here. These are a mix of countries. We've got Haiti showing that where the current is very far from the frontier, there are large efficiency gains that can be made. In contrast to Iceland, where there's very little efficiency. I mean, in Iceland, there's not much latitude for improving land use and land management. There's very few options. You can either have grazing for livestock or leave it natural. There's very little cropland and very little forestry, so there's kind of limited. And then you can see in some countries like low income, low population country like Gabon, which is largely forest, it does very well in terms of its environmental score and less well in terms of the net economic value. A country like Japan, however, is highly developed, does very well in net economic value and less well on the environmental score relative to what it could do. We can sum these up across countries to talk about what's the total gain moving vertically in terms of carbon sequestration that can be had without sacrificing economic returns, or moving to the right, how much gain can there be in economic returns without losses to biodiversity or greenhouse gas storage. Let me, in the interest of time, move quickly through this because I really do want to get to the last one. Oh, I do want to mention this one. The frontier shows kind of what's feasible, but the next question is in terms of policy, like how do you get from that baseline to the frontier? And we thought about showing kind of in steps, breaking this out. What are the most important types of land use changes or land management changes that get you to the frontier? So for example, just looking at the first 3 out of these like 10 steps. So looking at 30% of the changes that would be required to get all the way to the frontier actually gives you the majority of the gains. So there are particular places on the landscape that are really important for improving the economic and environmental outcomes. How you actually do that, though, is there are a variety of ways of then thinking about that. It could be more land use zoning or setting aside land as protected areas, but we could also think about many ways of using the price mechanism. So, we could think about payments for ecosystem services. We could also think about taxes that are applied to activities that reduce the flow of ecosystem services. So there's a number of different mechanisms that one can use in order to provide those incentives for people to take actions that improve the net benefits that flow, in this case, from land use. The last one I want to talk about is also work jointly with the World Bank on something that we call kind of Earth economy modeling. And this is actually linking the kind of ecosystem models that I've been talking about with a macroeconomic model, in this case, GTAP, the Global Trade Analysis model. So here, GTAP is a computable general equilibrium model. So a way to think about this is there is a CGE. We can run the CGE without ecosystem services. That would give rise to a set of actions, say change in land use or change in greenhouse gas emissions. We run those through the ecological or biophysical models to get the change in natural capital and the change in ecosystem services, which we can then put back into the CGE model in order to talk about how did that change something like GDP, or in the future, maybe GEP, talk about changes in trade and employment, welfare, and so on, the kinds of things that we would typically track in a macroeconomic model. A next step in this work is actually to think about this as a dynamic sequence. So each year you follow that sequence through from changes that decisions that economic agents make, changes in natural capital, ecosystem service flows, and then what are the set of benefits and costs that flow from those decisions. And then those go back in and start the next time period. So you can think about a dynamic integrated economic ecosystem modeling. We have done some of this work already and looked at analysis of what happens using this computable general equilibrium, what happens under business as usual, forecasted out to 2030. So how much, what do we lose in regional welfare from the loss of ecosystem services if we just keep going under business as usual? Interesting that the largest percentage losses are in low-income countries, which are most dependent on natural capital. Can we improve upon this? So we looked at 3 different types of policies. One is repurposing agricultural subsidies. A second is payments for ecosystem services. A local version, which is funded by taxes that have to come from within the country, and a global version where taxes can come, or the payments can come from high-income countries and be directed to low-income tropical countries, for example. And a third, looking at payments for agricultural research and development. And these can be tied together. So, for example, changing or repurposing agricultural production subsidies and putting that money into agricultural research and development. When we look at these kinds of policies, we can see that we get just measured in terms of GDP, not the non-market ecosystem services or carbon, climate change benefits. The blue bars, we can see these different kinds of policies generate gains relative to the business as usual. If we add in the avoided carbon damages, we get even larger gains. And we can talk about, because the GTAP model is a CGE, it's running for different regions, we can also track what's happening to the benefits or costs across different regions. And here we just summed it up over income classes. Where we'd love to go in the future is to think about combining these last 2 kinds of projects that I talked about. The frontier analysis, which shows what's possible given the resources of a country, and then this GTAP invest modeling, the integrated modeling, which shows what happens under different kinds of policies. So you can evaluate how effective or efficient various policy interventions would be. So I just want to leave you with one sort of last thought, which is The time I really applaud ADB for setting up this natural capital lab. The time is certainly ripe for this. So, if we think back to, where did we get the system of national accounts and where did we get GDP in the first place? The Great Depression, World War II really led society to realize the urgent need for better macroeconomic performance metrics such as GDP. Well, now we really are in the midst of what I'd call the great degradation in nature. And similarly, society should realize the urgent need for better metrics of ecosystem services and natural capital and ways of incorporating these into decision makings to help guide sustainable development. And with that, I will stop and I'll stop sharing, and Narayan, turn it back to you or whoever is next.
Thanks a lot. Yeah, thanks a lot, Professor Pulaski. That was such a rich presentation that absorbing this will probably take a lot more time than what was allotted to you. So in one sense, it is our misfortune that we could only have you for this much time, but in another sense, it gives us opportunity to invite you again for a longer session where, we could deal with these issues and understand them much better. And there were several interesting, ideas and interesting work that you just gave us a flavor of. So maybe I would like to, throw open the floor to questions. Before that, there was one small question on the chat box about the 233 billion tons of carbon sequestration that you mentioned, whether it also includes ocean sequestration or not.
No, that's just
easily answered on the chat too.
Yeah, it's sorry, I can easily just answer quickly. It's terrestrial only, not
So
marine.
Pulaski, you can't hear him. I think we can't hear him. Everyone else.
So I put an answer in the chat.
We apologize for all these technical hitches. Somehow we still seem to be not able to handle this. I saw an interesting slide, Professor, that you showed, which seemed to suggest that combining policies and I think subsidizing agriculture R&D are among the most effective ones for low-income and middle-income countries. So what does that imply for institutions like us, which are focused on development and especially to the needs of the low-income and middle-income countries? Would you have any thoughts on that?
Yes, can you hear me? Can you hear me?
We can hear you, Steve. It seems the room has an issue, but from our end, it's clear.
Yeah, it's. I think we adjusted it a bit now.
Okay, is this fine? Okay, great. Yeah, it's a great question. One of the things that I didn't realize before we did this analysis was actually how important agricultural R&D was, not for development, we've always known that, but for on the environment side. And the reason it's important on the environment side is that you can think about producing the required food either from existing croplands, and you can do that by increasing the yields, or you can expand croplands. And the expansion of croplands eats into natural habitat, which has negative biodiversity consequences and negative carbon consequences. So by increasing yields, you not only improve income for farmers, but you also save the environment.
Thanks a lot, Professor. I'm really, sorry that we have to move on because we've barely touched the tip of the iceberg, so to say. But I would now like to invite our Director of Environment, Yoko Watanabe, to deliver some closing remarks to this session. And we hopefully, can have many more sessions like this. Over to you, Yoko.
Okay. Hope you can hear me and also see me. Hopefully that's the case, everyone. And here? Okay. Not getting a reaction means I think you can hear me. So, yes?
Yes.
Great. Well, wonderful. Thank you so much. And thanks for the opportunity to provide you the closing remark from my side. This is truly a collaborative initiative between the AFNR, the Agriculture and Food and Nature and R stands for resources. I don't know. Rural development and also the environment team here in ADB. And it's been a great pleasure working on the Natural Capital Lab and this initiative. And this is remarkable that we are having the first webinar series today and really embarking on a new journey, navigating the complexity of policy instruments that are critical for nurturing and investing in our natural capital. So my first of all, deepest appreciation for the main speaker, the Professor Stefan Pulaski. This was really an amazing presentation. And as Narayan mentioned, I'd really love to hear a little bit more on the nuts and bolts on how these different data have come together. And it's really powerful to see how different policy measures can make a huge difference in both gaining both biodiversity, natural gains as well as economic gains and maximize and optimize the sort of gains for each side. And I really took note of, moving from the Great Depression to Great Degradation. We really need to take key actions, as you mentioned. And there are many different options that you have mentioned, like the land use change, as well as R&D, and different measures that we can take and the different outcomes that we can expect and simulate based out of these policy changes. And we'd love to learn a little bit more on the granularity, particularly on the Asia and Pacific and specific countries. I'm sure with your data, there's a little bit more that we can gain out of that so that we can apply to our different projects and programs and really optimize and see the balance between the economic gains and environmental gains. And I think this is really important that there is significant work done on the gross economic product as well as the global earth economy modeling, which is really impactful to see the different sort of impact of the natural resources we have and how we can address this with different policies. And I know that today we were expecting also Mary Ruckelshaus, the director of the Natural Capital Project, who has been spearheading on the work under her leadership on the Natural Capital Project with Asian Development Bank. And I think this has been a really important work to really assess the value of natural resources to economic terms and how we can really adopt different policy frameworks to support natural capital growth and ensure sustainable future for all. And I really feel that this is just the start of our conversation today. This is a series, so this is a great start, Narayan, and congratulations for your team and our team working on this. And we'll bring in different sort of angle to really see the nexus between the climate change, food security, biodiversity, and other socioeconomic impacts as we see today. And I think the shared knowledge from the webinar today can really translate into operational terms in different projects and programs that we work on, including wetland conservation through Regional Flyway Initiative, or the circular economy projects with marine debris and plastic management or agriculture, regenerative agriculture, and other initiatives that Asian Development Bank is working on right now. So with that few notes, in closing, I would really like to express again Professor Pawlowski and also my gratitude to all participants and also organizing team here. Sorry for a little bit of technical glitches and everything, but I'm glad everything went well. And let us carry forward the momentum for a series that continues. And thank you so much for the great participation of 65 plus participants, and hope you will join us again in the webinar series. So thank you again and have a great rest of the day. Thank you.
Thank you, Yoko. And thanks everyone. With this, we bring this session to a close. Thanks a lot.
Thank you. Thank you so much.